Hey guys, all right, so we are on 3.7, day 1, implicit differentiation. All right, so this will be day 1, and I'll just go ahead and give you guys what the assignment is. So for day 1, you're going to be doing page 162, numbers 1 through 11, odds. Okay? All right, so it says usually functions are expressed in explicit form, where one variable is expressed in terms of another. So the first example, y equals 3x squared minus 5. We have y is being expressed as x, and then a equals pi r squared. So the area is being expressed in terms of r. That's what they mean by explicit. But that's not always going to be how a problem is presented to us. Sometimes functions are written in implicit form. So examples of that would be x squared plus y squared equals 1. It doesn't say y equals or x equals, or x squared plus 3xy plus 2y squared equals 0. Again, it's not explicit x equals or y equals something. It's a combination of the two. And they're not easy to solve for a single variable. So in some cases, we can write an implicit function in explicit form, like this one down here, xy equals 1. Well, we could solve for x and get 1 over y. Or we could solve for y, divide both sides by x, and get 1 over x. So here it works. But if I were to try to do that up here, it wouldn't be as easy. And when we take a derivative, when there's more than one variable, we have to be very specific about what variable we're taking the derivative of. So x is what we normally take a derivative of. So anytime it's a different letter than x, we have to specify that, okay? So that is called implicit differentiation, and that is what this lesson is about today. It's easier to explain what implicit differentiation is by doing it. So we're going to do example 2. We are not going to do letter B, and we are not going to do letter D. So you can cross those out, because we're going to need the room for it. That's pretty much the only reason why we're not doing all those. All right, we're going to use implicit differentiation to find dy dx. Okay, so let's start by differentiating, so taking a derivative. So the derivative of y to the third is 3y squared. But this is a y, not an x. So I have to say dy with respect to x, the derivative of y with respect to x, plus the derivative of y squared would be a 2y, but again, not an x, so dy dx, minus the derivative of 5y is just a 5, but again, that's not an x, so dy dx. And then the derivative of negative x squared would be a negative 2x. That is an x, so we're good. And the derivative of negative 4 is 0. Okay, so far so good. Now, notice there's these three terms all have a dy dx, and then the negative 2x does not. Well, we're going to need to move that over to the other side so we can get all the terms that have a dy dx on the left. So I'm going to have 3y squared dy dx. Let me zoom in a little bit for you guys. Plus 2y dy dx minus 5 dy dx equals, if I add that to the other side, it'll be a positive 2x on the other side. All right. So notice all three of these terms on the left of the equal sign have dy dx. So guess what we get to do? We get to factor it out. So let's factor out that dy dx. So when we take out a dy dx from each of those three terms, we'll have 3y squared plus 2y minus 5 left. Okay, So we're trying to find dy dx. This is what we're trying to find. So I need to get this isolated. I need to get the dy dx all by itself. So that means I'm going to need to undo the multiplication here because they're next to each other. That means multiplication. Opposite of multiplying is dividing. So when I move it to the other side, I'm going to be dividing by 3y squared plus 2y minus 5. Okay. And this is what dy dx equals. So I'll just leave it as that. Okay. So it's not so bad. They're actually kind of fun. I like them. So whenever you have more than one variable, when you take the derivative of x, you do that normally, whatever, product rule, power rule, quotient rule, chain rule, all that's still the same. Nothing's different. It's just now we're adding in another variable. So when we have to add in a different variable from the x, we have to make sure that we write like the dy dx. So if it were an m, you would put dm dx. If it were an r, you would put dr dx, that type of thing. So on and so forth. All right, let's take a look at letter C. And let's just start differentiating. So the derivative of x cubed is 3x squared, and it's an x, so we're good. Here, though, we have two terms being multiplied together, so we're going to have to use product rule. So the first term can be the negative 2x squared. So so first term times the derivative of the second. The derivative of y is 1, but it's not an x, so dy dx. Plus the second is the y times the derivative of the first. The derivative of negative 2x squared is a negative 4x. Okay. Plus, hey, we're going to have to use product rule on that also. So the first term is a 3x times the derivative of the second term, which is a y squared, so 2y, but it's a y, so dy dx, plus the second term, which is a y squared, times the derivative of the first was a 3x, derivative of 3x is 3. That's an x, so we don't need to worry about anything. And the derivative of 38 is 0. I need to back this out a little bit. Yeah, that's a long line, and that sometimes happens, but it's okay. So let's take note of the things that don't have a dy dx attached to it. Like 3x squared, we're going to move that to the other side by subtracting it. And that has a dy dx. This one does not, so we're going to move that over. And when we multiply that together, that's a negative 4xy. It's proper to put the letters in alphabetical order. And so when we move this to the other side, we're going to add it because it's negative. And then this one has a dy dx. This would just be a 3y squared, and it's positive. So when we move it to the other side, it would be a negative 3y squared. All right, so let's rewrite this. So we're going to have negative 2x squared dy dx. I'm just going to write all the dy dx terms because all the other ones are going to be moving. That's moving. This one will be a positive 3x times 2y is a 6xy dy dx equals, well, the first term that moves over is the 3x squared, so it's negative 3x squared on the other side. The next thing that moves over is the negative 4xy. On the other side, it's a positive 4xy. And the other thing that moves is the 3y squared. When we subtract it, on the other side, it'll be negative 3y squared. Okay. All right. So again, we've got to factor. That's the next step. So we're going to factor out that dy dx. And we'll get negative 2x squared plus 6xy equals negative 3x squared plus 4xy minus 3y squared. Okay, and we need to solve for dy dx, so we're going to need to get rid of the product there, negative 2x squared plus 6xy. So to undo multiplication, we divide, so we're going to divide it on the other side. And I can't simplify that any further, so I'm going to leave it like that. See, it's really not that bad. It's pretty good. I like these. And I know I say that about a lot of things, but there will be some things that I don't like. It happens. All right, letter E. Sine of x plus 2 cosine of 2y equals 1. Well, on this one, we have a function within a function, so we're going to be using chain rule on that. Okay, so let's get going. The derivative of sine x is cosine x. Plus, there's a 2 out front, so I'm just going to keep that coefficient out front. And when we do chain rule, we do the derivative of the inside. The derivative of 2y is a 2, but it's a y, so dy dx times the derivative overall. The derivative of cosine is negative sine of the inside, which is 2y, equals the derivative of 1 is 0. Okay, let's clean this up a little bit. So, since we have 2 times dy dx times negative sine of 2y, these are all being multiplied together. So I'm going to bring down the cosine of x. There's a negative. Negative times 2 will be a negative 4 out front, then sine of 2y, and then we could tack on the dy dx at the end, because it usually goes on the end anyway. Equals 0. All right. So now we need to move the cosine. So let's move it to the other side. When we move it to the other side, it's going to be negative. I'll throw it up here. So I'll have negative 4 sine 2y dy dx equals negative cosine of x. Okay, and now we're going to need to get rid of that negative 4 sine of 2y. That's in front of the dy dx. They're being multiplied together, so we have to undo the multiplication by dividing. So we'll have dy dx equals negative cosine of x over negative 4 sine of 2y. We have a negative divided by a negative, so that is positive, and I can't do anything else, so that's it. Cosine of x over 4 sine of 2y would be the derivative. That is implicit differentiation. All right, turn the page. We have one more example, and that is example 4. We're going to write the equation of the tangent line. So anytime we've learned something new with derivatives, I think you guys have noticed by now, we'll always ask you to use that new method to write the equation of the tangent line. So that's a very, very important skill. So since we are really hitting you hard with that skill, do you think it's going to be on the AP test? Yeah, it's going to be. So we got to get good at it. And the only way to get good is to practice, practice, practice. So we're going to write the equation of the tangent line to y squared equals x at x equals 4. We're not going to verify it graphically because we're doing it algebraically, so no need to do it twice. Okay. All right, so here we go. Here's the setup. We know that we need to take a derivative, okay? So, and we're finding the tangent line, so we're finding t of x, okay? So we're going to have the slope out front there, whatever that is, times x. We know that x equals 4, so x minus 4. Plus whatever the y value is, okay? So we do need to find that y value. So let's go ahead and work on that first. Let's plug it in. So we'll have y squared equals 4. And then to solve for y, we have to square root both sides. But whenever you're solving for a variable and you have to take a square root, it's plus or minus. That answer, square root of 4, is plus or minus 2. So since I have 2 y values there, that means I'm going to have 2 equations for a tangent line. So this will be my first one. We'll have the plus 2 on this one. We just need to find the slope. And then we're going to have the other one. It's going to have the same stuff, whatever the slope is, times x minus 4, but a minus 2 on the other end. So that means that there are two lines that are tangent to the equation at x equals 4. Okay. So let's try this out. Let's find the derivative. That is the next step. Okay. So we have y squared equals x. So let's take the derivative. So the derivative of y squared would be 2y, but that's a y, so dy dx. And the derivative of x is 1. Well, we need to solve for dy dx. So we're going to need to divide both sides by 2y. So dy dx equals 1 over 2y. But remember, we have two y values for y, a positive 2 and a negative 2. Okay, so let's try those out. So when we plug in a positive 2, so I'm just going to be like, meow. So 1 over 2 times 2 is a 1/4. So the positive one, the one where we plugged in a positive 2, has a slope of 1/4. For the other one, it'll be 1 over 2 times now the negative 2. That's going to equal a negative 1/4. So when we plug in a negative 2, the slope is a negative 1/4. So it doesn't just go anywhere. It has to go with its respective y value. Okay. Well, so that's a first, having to do two tangent lines for one problem. I don't know why I wasn't focusing. Okay, but not too bad. We just have to tie in all the concepts together. All right, that's it, you guys. So your homework we had written down on the first page, and that's it. Have a good one.